Now we're going to look at some polynomial features. On number 19, we got f of x equals x squared and g of x equals negative 2 x plus 3 squared minus 4. So let's think about all the transformations. Well, the x plus 3 on the inside is going to move it left 3. The minus 4 at the end is going to go down 4. The negative is going to reflect over the x-axis. And the 2 is a vertical stretch by 2. So what that's going to do is it's going to take all the y values and double them. So let's start with x squared. So when x is 0, 0 squared is 0, 1 squared is 1, 2 squared is 4. And then we'd have a mirror image. So here's my parent function. Now, if I move it left 3 and down 4 and reflect it, normally you go over 1, up 1. Here it's going to go over 1, down 1, but then I got to multiply by 2. So it's going to stretch it by 2. Next, number 20. Number 20 asks, is x minus 2 a factor of p of x, which is 2x to the 4th plus 5x cubed minus 8x squared minus 17x minus 6. Now, the fastest way to figure out if it's a factor is to do synthetic division. If I get 0 as a remainder, it is a factor. So in synthetic division, we write down all of our coefficients. And then if this is x minus 2 equals 0, I'm going to put a positive 2 out here. Bring down the 2. 2 times 2 is 4, add down. 9 times 2 is 18, add down. 10 times 2 is 20, add down. 3 times 2 is 6, add down. The answer is yes. Number 21 says to factor completely. Now it doesn't say to solve, just to factor. Well, the first thing I notice is that everything's divisible by 3, but I don't like the negatives out front, so I would actually factor out a negative 3. Now, I can't factor that. What I would do next is see if I have any really good zeros. So I'm going to type in the original. And I'm going to go to the table and see if I have any good zeros. Oh, I do. 2 is a 0. Let's look at the graph. Two is my 0. So I know if 2 is a 0, then x minus 2 is a factor. 2 is a 0. X minus 2 is a factor. That means I can divide what's left, whoops, by x minus 2. So I put 2 on the outside. I'd have a 1, a 1. We're missing a term. So 1 times 2 is 2, add down. 3 times 2 is 6, add down. 6 times 2 is 12, add down. And I'm left with x squared plus 3x plus 6. That is my other factor. X minus 2 times x squared plus 3x plus 6 gives me x cubed plus x squared minus 12. Now, in the original problem, there was the negative 3 still out front, so that has to stay. Now, since it didn't ask me to solve, I have to stop. So on 22, it asked me to first find all the possible roots and then find all the real roots, like then solve it. So let's talk about how to find the possible roots again. We're going to take the factors of the constant divided by the factors of the leading coefficient. So factors of 15 would be 1, 3, 5, and 15. I'm dividing by 1. So that's easy. Plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Those are my only options. Now, we want to see if any of those actually work. So personally, I would go to my calculator. And I'm going to look and see if any of those work. I guess I should have checked negative 15. Nope. Oh, negative 3 works. Oh, no. Is that the only one that works? Oh, the other ones are going to be ugly decimals. So I need to use synthetic division. I'm left with x squared plus 0x minus 5. That gives me x squared minus 5 equals 0. X squared equals 5. X equals plus or minus the square root of 5. Notice how finding one rational one made it super easy to find the rest of them. Now we're going to be doing something similar with 23. But we're also going to add in knowing whether something turns around or touches at each of the x-intercepts. So 2x to the 5th, whoops, plus 6x to the 4th minus 18x cubed minus, whoops, 54, gosh, x squared. Now I notice that all of them are divisible by 2 and they all have some x's. So I'm going to go ahead and factor that out. So I'm going to have 2x squared and that leaves me x cubed plus 3x squared minus 9x. That would be minus 27 there. Ooh, I think I see something pretty here. So I'm going to try doing factoring by grouping. So that's got x squared in it. These, I could take a -9 out. Cool. So I got 2x squared. I have x plus 3, then x squared minus 9, but that factors again. Now this is going to be a double root. At x equals 0, it's a double, so we're going to get a bounce. At x equals -3, I'm going to get a bounce. At x equals 3, I'm not going to get a bounce. It's going to cross. Now, could I have also done that one in the calculator? Excuse the bell. Let's see if we could have gotten the same results by just looking at the graph. First off, I could have gone to the graph. Now, it looks like it's hitting at -3 and 0, but I need to check the table to double check. Notice that at 3, I go from a positive y value to a negative y value, so it's got to cross. At 0, it is an x-intercept. My y value is 0, but it goes from a negative back to a negative, so it bounced. Same thing at -3. So yes, I could have gotten all that information from the calculator as well.